Good afternoon, everyone. My name's Carolyn McBean and I'm the Parliamentary Librarian. Firstly, on behalf of the Parliament in Victoria and its members, we gather to acknowledge the traditional owners on which the land we gather here today. We pay our respects to them, their culture, their elders past, present and emerging, and we also pay respects to people from First Nations communities who may be joining us here today. I welcome you to our seminar today about artificial intelligence and biometrics. This wasn't done by ChatGPT, by the way. So we're presenting that jointly with ATSI, which is the Australian Academy of Technology and Engineering. Our moderator is Professor Sandra Kentich, who is the chair of ATSI, the Victorian Division, and Redmond Barry, Distinguished Professor at the University of Melbourne. Please note that when we get questions later on, we'll have a roving microphone, and so please wait for that to arrive before you ask the questions, because we are recording this. So I'll hand you over to Sandra and enjoy.
Thank you, Caroline, and it's my great pleasure to moderate this very timely science and technology presentation on artificial intelligence and biometrics. And this is a very important discussion for us to be having because AI is increasingly widespread across many sectors, and it is being coupled with biometric applications where individuals are identified based on their biological characteristics or behaviour. And this includes, of course, facial recognition and fingerprinting. There's rapid growth in this field being led by increasing computer power, allowing techniques such as deep learning to be readily deployed. And it's my great pleasure to introduce our eminent speakers on this topic today. And I'd note they both have distinguished careers, widely recognised as international experts in their field. So I'll introduce both speakers. Our first is Professor Joanna Batstone. She's the inaugural director of the Monash Data Futures Institute at Monash University, and I should add, a recently elected fellow that's just been announced of the Academy of Technology and Engineering. So her institute brings together data science and AI capabilities from across the university in the areas of health sciences, sustainable development and policy and governance. Prior to joining Monash University, she was Vice President Innovation for IBM Corporate Strategy based in New York, and she's held many other senior roles at IBM, including Vice President and Lab Director of IBM Research Australia and Chief Technology Officer for IBM Australia and New Zealand. She'll be followed by Professor Din Fung, who's one of the world's leading experts in machine learning, deep learning and generative AI. Din has worked with a number of companies using technology that centres around face detection, face matching, OCR and fraud prevention. He was a finalist for the 2020 Australian Museum Eureka Prize for Excellence in Data Science, and he's currently an associate editor for the flagship journal of Artificial Intelligence Research. So I'll pass over now to Joanna, who will give the first presentation. Thank you.
Thank you very much, Sandra, and it's a delight to be here with all of you today. I thought I would start with, in essence, an introduction. We hear a lot about artificial intelligence, but I would guarantee that if I asked every single one of you in the room, how would you define artificial intelligence, we'd get at least 20 different answers. And so I thought it might be worth here just framing the different words that are used when we talk about artificial intelligence. We hear about deep learning and machine learning, but artificial intelligence is actually a whole suite of capabilities, applications, technologies that fall under the umbrella of the term artificial intelligence. And it includes things like vision and speech and language and logic and reasoning. And all of these technologies come together and in essence become the field that we now know of as artificial intelligence. One of the things that's been really clear over the last 12 months is the expression artificial intelligence has really grabbed the public's attention. And very much because of all of the noise and discussion around new technologies, including generative AI. And so as we think about where we are today from a societal perspective, the conversation is amongst us. It's amongst the people in society, it's amongst the researchers at universities, it's in industry, all looking at how do we optimize the opportunities associated with artificial intelligence, but also mitigate some of the risks that society raises for us. My colleague Din is going to explain much more around how generative AI really works, but I thought it was worth just highlighting a couple of examples of generative AI technology that really have hit the press in the last 12 months. It's not just about ChatGPT, which is my next slide, which is more language-centric, but it is about the ability for AI technologies to generate new content, including image content. And so one of the image generation tools, again released by OpenAI, is this tool called DALL-E. And it's a really interesting tool. Students love it. It's very interesting from a design perspective to look at how to create new imagery and art. But it's only as good as the content with which it's been trained. And so on the left, you'll see some examples of a bicycle, which actually look like a bicycle and you'd recognize as a racing bicycle. And the prompt that was given in this case was, show me a painting of a racing bicycle. So that seems pretty straightforward. On the right, though, I'd actually asked here for an example of an oil painting of the National Gallery of Victoria. So you can tell immediately that that's not the National Gallery of Victoria. You could also argue that it looks like a gallery. It looks like something that could be a national gallery. It's not clear that it's Victoria. But it gives you a sense that as you're creating prompts, the content that you get back from some of these generative AI systems has to be determined as to its validity, accuracy, truthfulness, and it's all based on the information these systems are trained on. It's also clear that there's been a tremendous amount of hype and discussion around ChatGPT. We even heard it in our introductory remarks that the speeches were not written by ChatGPT. ChatGPT really is a dialogue engine. It's very interesting, very powerful, but it's really a statistical approach to generating the best set of responses given a set of prompts. And so with all of these systems, they are algorithmic, they are statistical, they are all trained on huge amounts of data. And one of the big questions around ChatGPT has been around the authenticity or legality of the data sets on which it's trained, and also whether it represents the diversity of the community that is now trying to use some of these new tools. So you'll hear more about generative AI from my colleague. But I wanted to move on to the application of AI in biometrics. Because a lot of the time we think about, well, why are we talking about biometrics and AI? AI can make biometrics evaluations faster, but is it actually more accurate? The main use cases around biometrics fall into identification and security, and also surveillance. And it's very interesting as you survey the general public in terms of their apprehensions around artificial intelligence. Facial recognition is one of the very emotive topics when we talk about artificial intelligence. And yet there are many use cases around AI and facial recognition that we like. I personally find it very convenient to be able to unlock my smartphone. I like it when I can speed through the immigration gates at Melbourne Airport. I get a little more concerned in the context of am I subject to surveillance with CCTV cameras going around? So every one of us will have a different sense of what makes us comfortable, what makes us nervous. But it raises questions about privacy, data privacy, responsibility of data, and also human rights. Are some of these data sets used to disadvantage certain populations and communities? And so although we've got many use cases where we like facial recognition as a use case, particularly when it's one-to-one, there are also cases where we have to look at some of the risks associated with this. So one-to-one facial recognition, that's like me and my mobile phone, or me and my passport photo as I'm going through the immigration gates. But what about tools to help police identify criminals in a crowd? That's no longer one-to-one verification. That then falls into the realm of surveillance. And that has other challenges associated with the accuracy of the data sets. So I'm going to spend just the next couple of slides talking about facial recognition in the context of what we see and what we hear and what the public tells us are their apprehensions and concerns. And then I'm interested, as we get into the question and answer session, to hear your views of both opportunities and risks with some of these new technologies. Inherently, when we talk about biometrics data, we're talking about personal data, people data, data that could be associated with me as an individual or any one of you as an individual. And hence, the ethical concerns around how we think about biometric data become really, really pertinent. And as AI started to be embraced as a way to improve capabilities around biometrics, certainly in the context of facial recognition, many of the algorithms were trained on data that was publicly available on the internet. Hundreds of thousands of images that were scraped off the internet. And so this would have been back in the 2015, 2016 time scale as major tech companies were creating capabilities for technology for facial recognition. A lot of it was done using publicly available data. One of the challenges with that is around who gave the consent for that image of a face to be used. And so consent becomes a really important part of, are we being trustworthy and responsible in the way that we're developing these algorithms? And so one of the challenges then becomes racial bias in the data sets, the annotation of a data set, many examples where we saw unfortunate misidentification of racial minority groups within data sets that then gives rise then to bias in the way that those facial recognition algorithms are used. And so what results then is governments around the world have been looking at how to regulate and what laws or privacy acts may be required in order to ensure responsible and safe AI. And that's a discussion that goes on in Australia today in the context of responsible AI, particularly from an industry adoption perspective. Now, one of the consequences of the risk of facial recognition is in about 2018, most of the major tech companies actually came up with bans on using facial recognition algorithms for use in police surveillance operations. It was viewed as a use case that was too risky. And so the tech companies stepped back. It's a very tricky area because the tech companies also want to be able to sell that capability into non-risky use cases. But in the context of police activity, it was absolutely restricted. And the regulations are still changing as we think about the application. And so a couple of examples for us to think about here in Australia. There are a series of ethical considerations for us to look at. The two articles on the left come from the journal Nature that has done a number of articles on artificial intelligence over the last 5 years or so, looking at, again, both the opportunities and the risks associated with adoption of new technology and the impact of those new technologies on society. So there are a whole series of ethical questions that each one of us has to think through. As a researcher, what does it mean for me to do responsible research? In the middle example, this is an example of a trial that was going on around using live facial recognition to be able to do surveillance and to identify potential criminals in a crowd. Now, on the right, this is much closer to home. For those of you who go shopping in Woolworths, you may have noticed that this is a sign from Woolworths that shows camera technology trial in progress. You'll see this at the supermarket checkouts. Now, the trial is around ensuring that what you've put in your basket and put through the checkout is in fact what you've bought and paid for. But again, it raises the question around what are the privacy policies and regulations that are in place for any company or any industry that is using AI facial recognition. The nice thing about this is if you go to the Woolworths website and look at the privacy policies for Woolworths, it very clearly describes to you how the data is being used and for what purpose. And so that open and transparent use of data is one of the things that we need to be looking for. I've talked about the challenges with the police. I've got 2 more slides here. One of the reviews that Nature did was to look at where are we comfortable or uncomfortable with facial recognition. And I realize that the words on the chart are probably really small for you. But if I go right to the top of this chart, the colors, the really light color is people who are really comfortable, and on the left-hand side, the really dark color is extremely uncomfortable. So right at the top, police identifying a suspect after a crime. People are generally okay with that. If you go right down to the bottom of this chart, people are really uncomfortable with using facial recognition for anybody looking up somebody's identity. That feels an invasion of personal privacy. But there are a whole series of questions in the middle that are really questionable as to which way would we land as we think about this ethically. For example, do we like passport checking as we go through immigration? Yes, but what if public transport systems are using surveillance on, for example, metro trains here in Melbourne? How do we feel about schools assessing students' behavior in the classroom using video analytics and facial recognition technology? A lot of some uncomfortable things to think through from an ethical perspective. So one of the ways that we can think through ethical use of facial recognition is to think through how can we be responsible around collecting the data sets for facial recognition. And so I'm going to wrap up with one responsible use case that I think is pretty interesting, which is work that's underway at Monash University and the Australian Federal Police. And so again, back to police and surveillance, this is actually a use case with the police around looking to prevent child exploitation. And if you think about child exploitation, that implies pictures of children. Children cannot give consent for their photograph to be used in a training set of data that could be used to develop an application for training. However, all of us as adults, at one point we were children. We as adults can give consent for our photographs to be contributed to a data set. And so this particular program of work that we have underway is around, we call it My Pictures Matter, but it is around gaining the consent of us as adults to submit our pictures of ourselves as children to build a data set of photographs of children that can then be used as a trusted and safe data set that then the federal police can use in some of their child exploitation prevention analyses. And so although we have a big emotive dialogue around facial recognition, it's not all bad. There are use cases that can really make a difference. And I think this is an interesting example of how we've got responsible use of AI, but it actually does then relate to the way that we can enable our police departments around the world to be responsible in their use of some of these new technologies. So thanks very much, and I'm going to hand over now to Din for the next part of the discussion.
Thank you very much, Joanna. Good afternoon, everyone. Thank you for the invitations and the privilege for me to share my thought on this topic today. So I'm Din Phong from the Department of Data Science and AI. And so Joanna already covered pretty good pictures and the importance of AIs and biometrics in today's society. What I would like to focus on my presentation is how is it going to be in the future in the age of generative intelligence. In the interest of time, some of the slides that I've been prepared, I might go faster. But what I would like to start with is the fact that now today we can collect and store data in a very massive data set can be collected, and they are fueling AI revolution this day. So in this data, what are the biometrics data, right? So from the days that we are born, one of the biometric data or biomedical data is the one that relates to our face and our voice, etc. And then what it comes is that these are the biological signals that we are born with, right? But now today, what happened is that the revolutions in wearable and sensing technologies has enabled us to capture all of this data in a very unprecedented way. So what is being transforming is not only the biological data you can be captured, for example, your heart rate and so forth, but also what it means is the behavioral data as well. And this behavioral data is the thing that you can use to also identify and analyze someone's behavior or someone's characteristics or signature. Okay, so I think that I would like to walk through a few useful concepts when we talk about biometrics authentications. So what I plan to do is, in addition to what Professor Joanna Basson just presenting, I might give you a few ideas and the concept and demystify some of the important concepts. So let's say that some of the system that working is like this, and this is what they call is a KYC example, and it's very similar when you go through an airport. So you go there and then you present a document, let's say a passport and so forth, and then you take a selfie, right? And then what it does is that AI will perform a detection stage. It will detect the face, and then it perform a recognition or matching between those two, right? And then what's next is that it will try to determine if the person instead of the camera or in front of the phone is actually the right person. So, because in some cases, people can spoof that. For example, I can take a photo of myself, put in front of the cell phone instead of myself. So that's called live neck detections, and this is also very important. And then next, what it does is that the AI will extract the information from the document, and then it also check whether or not the document is genuine or not. For example, it's being tampered, it's being fake, etc. And then, so about that's done, then it will do a face retrieval using face technology, looking into the database of one of the customer and see whether or not this person is already in the database. If it is there, then it will say that you're already there. If not, then it will be onboarding, right? So this is an onboarding process where a customer can now enable and open a bank account, for example, in 3 minutes instead of you have to go to the bank and wait for a few hours, or in the past you have to wait for a few days. And there's about 4.5 billion people in the world doesn't have access to the bank just because they don't have this evidence and be able to prove to the bank that they can open the bank account. And this technology, for example, will enable a very fast onboarding process of the bank. And this is an example of how AI these days can accelerate innovations in our society. But what I really want to highlight is the process of biometrics in this place. In this particular example is the face technology. All right. Now, once you finish with onboarding, something that you read on the news, for example, usually they say that they have a 99% accuracy or 99.999% accuracy. I would urge you to reconsider and ask the question, because there's two concepts. It's called false acceptance rate and true acceptance rates, right? So when you talk about accuracy, it actually fixed to a certain level of false acceptance rate that you're willing to accept. So sometimes the company or some technology, they advertise that their accuracy is 99.9%, but then the question is, what is false acceptance rate, right? So that is a very important concept that you might pay attention to. Now, in my next slide, I really want to say one thing, right? Biometrics that we've been talking about these days is mostly about authentication and tracking and identifying people, but also these technologies have a much deeper values. What I call is insight and analysis. If you look at the face analysis, for example, it's not about recognize the face or detect the face, but also try to understand the human, the emotion of this person. Is he angry? Is it sad? Especially, for example, if you look at self-driving technology, then is the driver is drowsiness, is he sleepy, and so forth. And then also in medical domain, it have a mass application. One example, very obvious, is if you know about those autistic children with autism disorder, for example, they usually don't have a very good eyes contact and so forth, then you can use this technology and track, all right? Okay, so that is maybe my 2 cents on the biometric system and how it works. So then we talk a lot about machine learning and AI and so forth. So how machine learn? So I just want to give a very quick example, right? So let's say that we care about the environment and we want to detect whether or not an image is a fish or something living under the water. The usual procedure for a machine or the algorithm would learn is that they will collect the data, and then you will label that data. You will say, is that a fish or not a fish, right? And then you train a model, and then you deploy it into the system, when in practice, and then you repeat this process until the accuracy is really increasing. So this is what it meant when we say that we use a lot of data and use data to fuel machine learning. It's because we need this data. I want to take that so that the machine can fit on it. So what does it by training? Training is basically a function that it can map from your image into a label. So let's say you have an X coming, and you say whether or not it is a fish or not a fish, right? So basically, it's a mathematical function. And deep learning, this is the key word that you hear. So basically, this function is a deep neural network. So it's called pretty much a deep learning. I'm oversimplified it, but basically that's what it is, right? So the important thing to notice is that until on the way to 2022, all we're talking about AI is basically about recognition, being able to recognize something. And it do so well at this, right? So in fact, in 2015, there's a challenge, and the first time the machine has beat humans in perceptual recognition. The error rates that the human have is about 5% for 1,000 category that you need to classify. The machine is about 3.5% of error. So the first time, and this is where fewer and AI becomes so important, and everyone talk about AI because for the first time it's been proven and so forth. All right, so that's up to 2022, right? Now, what really important is, let me talk about the future now. Let's starting from 2022. So now, and then here is, I want to touch upon the concept of generative intelligence, right? So people usually use the name generative AI and so forth. It comes from a suite of what they call is generative model, or what I call now here is generative intelligence. So let's say I start with the same deep neural network that you've seen before, that you have an image input and then you output a concept called beach, right? But let's say generative is like this. Instead of you give an image and you say, tell me what is it a cat, a dog, or a beach, or a fish? Let's say that if we give you a concept, let's say beach, what's going on in your mind? Let's think about that. Let's imagine what's going on in the mind. So you sort of reverse the deep neural network, and then when we talk about beach, different things coming, right? It's tropical, it's stormy, it has different kinds of color. So many scenarios that is going on when we talk about a beach concept. Everyone might have a different version of the beach as well. And this is what it means by generative intelligence, right? And then it starts to captivate the researcher and everyone, because for the first time the machine is able to start to do something which is at the very core of the human intelligence. That is creativity, being able to imagine and generate things, right? Okay, so then what I'm saying on the way to 2022 is about recognition. Generative model is about taking the data, learn from it, and then be able to generate, right, imagine and create new content. So I would say that from now on, AI is probably no longer just narrow AI, just recognitions anymore, but it is recognition and also generations. 2022, 2023 is actually really the years of generative AI. I don't have to talk about that. Everyone's talk about ChatGPT, DALL-E already, and my colleague Joanna Baston already talk about it. What is significant is for the first time, for example, an app like ChatGPT, it can acquire 100 users in only 2 months. It would usually take years to do so, right? And you can see that the speed of technology is increasing. It's not just linear anymore. It's exponential in that way, right? And the key technology of this, of course, I won't go into the detail, but I thought that I just put it there so that in case someone come across, you will hear it, or you can impress someone if you can remember this. So variation autoencoder is one technology. Another one is generative adversarial networks. In 2014, diffusion model come around in 2000 and 2021. And then the last one is transformer. So ChatGPT stands for GBT, so generative retrained transformer. So this is what it means by transformer. It's not it's a mystery or anything like that. Transformer basically is the way that you can model how you can pay attention to the context. So if you can model a data X, and they can look at the data X minus 1 in the previous timeline, that's what you got. Yeah, okay, so generative AI, not only it can generate a really interesting images and things like that, and video, you've seen many of them. For example, the one at the top, at the bottom over there, really cool, is a style transfer. If you have a horse, you can translate it into, a zebra and so forth. But it can also generate a lot of photo. It can also generate like face, handwritten notes, molecular structure, DNA structure, and then it can create sort of like very artistic photo of people as well. All right, I skipped that what I'm saying there. Now, my slide here and my last slide, I would want to think about rethinking biometric technologies. Now, in my first slide, I talk about how biomedical data and biometrics data is captured. Imagine if the machine is so good at generating all of these fake biological signals. What it means is all of the current technology will still work or not. And in fact, we have so many examples of that happening, right? So on face, there's the people who, those guys who can bypass the locking by generating the fake exam face. At the bottom over there, you can see the deepfake that in operation. In the middle over here, these days we heard about those AI voice scam that they're calling. And then, for example, now the scary thing is, with only 3 seconds, they can actually clone your voice. So, for example, they call and you have a missed call, and you say, hello, who are there? And then that's enough for them to do, all right? So let me just play this one, and then you can hear it, for example.
Hello, this is my real voice, and this is the fake voice I've made using an AI voice cloning program.
Right. And then not only that, they can also fake fingerprinting, okay? All right, so my final remarks, so what's next? Okay, so I would say that the bright side is that this technology is going to be more and more accurate, and I would emphasize the fact that it's not just biometric authentication. You can use this for so many use cases, including like fighting mental health, suicide preventions, identify missing children, and so forth. On the dark side, because it's now, it can so good at faking stuff, then how can you tell the truth from the thing that is not true? All right, and then I would say that it's probably the biometrics technology industry might need to rethink and to have a reboot about the technologies. And then in terms of what I thought that it might be useful to think about is now that we need to ensure the responsible use of AI that Joanna has been talking about. We need to enforce the traceability and the accountability for generated AI technology, especially those content that is generated. And lastly, I think that we need to enhance the features and the AI capability so that we can stay up to date and continue to drive this revolution forward. Thank you.
Thank you, Dan. And we now have time for questions. I have a number of questions here, but I'm wondering if there is a burning question from the audience first, in the interests of time. Yep.
Thank you. Thank you very much for your presentations. Can you tell us if there's been much work into the space of who owns the content that the generative AI models are putting out? Like, for example, if someone jumps into ChatGPT and it spits out some info to you that you then use for profit or that you then use for something else, like who owns that content or the intellectual property around that content? And the same goes for like images and other things.
Yeah, that's a really good question. So it's been an evolution over time. So in the first releases of ChatGPT 3 and 3.5, the content had been scraped from a number of different sources, and OpenAI will tell you some of the sources that they've used across the internet, but don't necessarily share everything that they've used. And so you'll also be aware that there are lawsuits underway from authors who claim that their copyright has been violated in the way that those data sets were created. And so a lot of debate and discussion around the ownership of that data set. OpenAI would claim that that's their data. Most of it was gained through the public internet. So as soon as you put something out there in the internet, it's in the public domain. But one of the big questions is around copyrighted material. Moving forward, though, as newer versions of ChatGPT come out, so ChatGPT 4, for example, if you want to use ChatGPT within your company or within your government or within your office, ChatGPT 4 gives you the option to turn off data sharing. And so one of the questions has always been, as we think about some of these technologies in widespread use within government, how do we avoid sharing confidential material back into that public data set? And so one of the switches, in essence, that's now been enabled in more recent versions is the ability to turn off that data sharing back into the host. And that opens up many more opportunities for use within enterprise, within government, within universities, where you can put proprietary data into a ChatGPT system, but not have all of your proprietary data then shared into the core base language models. It's a very active area of debate right now. And I think we'll see more discussion around, well, how do those large language models get built? For example, within Australia, should we be building our own large language models around particular areas of industry where we have expertise here locally, and we want to preserve that intellectual property? So it's a really good question and an open-ended answer in terms of where the technology will go.
I might. Well, I'll just ask a question for myself first. In terms of where we are in Victoria, this is obviously a very fast race with many large companies and large governments playing in this space. What's the role of, how can Victoria play into this space? How can we is there an opportunity for us to take a lead role in development and deployment of these technologies and services? And if so, where are our strengths and what skills are we missing? I'm going to ask Din.
Thank you, Sandra. Yeah, so for me, one thing that I think is really critical is the talent and building the capabilities in AI. And I think Victoria and Melbourne in particular have one of the elements that we can be on the same bar with those big hub in the world like Amsterdam or Toronto. So probably Silicon Valley is a bit too difficult, but I think to that level we can attract talents to stay. For example, we have a better visa program for students, or for better support and investment in research and development, startup ecosystem, building ecosystem, and so forth. In terms of the verticals, I think that Australia, we are easily, world-class medical research facility and support, and the medical research is very important, including many hospitals and so forth. So I think that health and medical is an area that we can focus. Another one is on energies and sustainability, for example.
Thank you, Din. And we will now take that next question.
Sure. Thank you both as well for coming in. It's perhaps quite an existential question, but there's quite a lot of debate and noise around it, as you said at the moment. I guess I just want to ask both of you, should we be worried? Like the risks, like Deng, you spoke a bit about the dark side of these developments. There's obviously a lot of great applications for it, but these comments that we see about it being a great risk to humanity and the planet and all those kind of things, should we be worried? Is it okay? Is it somewhere in the middle? I just sort of wanting to get that sense. Either of you. Yeah.
All right, so I can say a few words. So I completely don't agree with Elon Musk on this. And I have a bit of good news is that I have a colleague who's been working and analyze this large language model in very detail. What I can tell you from my best of knowledge as a researcher in this field is that on of those language model and ChatGPT and so forth, they are still statistical correlations, nothing, no less. So, you enter a sentence, and if we try to predict what is the best words that it can happen next in terms of probability, and you can imagine you have so much data, it becomes so accurate. But that's the reasons why you also see a lot of hallucination, because it look like that it read very natural, but then completely wrong. It doesn't make any sense. Besides of that, if you look at the chain of thought, reasoning, and understanding, it almost doesn't have a much level of understanding. For example, if you do arithmetic calculation with ChatGPT, if you try like 22 plus 57, for example, then you test that it will be, most of the time, it will be wrong, right? So, I mean, if a child learn 1 plus 1 equal to 2, and then you ask what is 1 plus 2 equal to, they probably can make deductions and make it an answer 3, but this language model will completely screw up at this kind of task. Yeah.
The thing I would add as well is that as we sort of look back historically around where there have been these major shifts in technological innovation and revolution, if you stick your head in the sand and hope that it'll all go away, it won't all go away. It will just accelerate faster and faster. And so some of these discussions around what does it mean to have safe and responsible AI, those are the conversations to engage in. With any technology, there are always nefarious actors who will come along and try to disrupt. But again, in the context of responsible AI, we've got to look at this in the context of the opportunities. Where are the risks? How do we mitigate and address the risks? And that does include talent. And it also includes understanding, is it the technology we're scared of, or is it the application of the technology to a particular use case that we're scared of? And it's usually the application of the technology as opposed to the technology itself. And so I've been in this world of AI discussions for probably the last 10 or 15 years, and it's just going to go faster and faster. And I think it's a tremendous opportunity from a business and economic growth perspective as well. And so we have to be very proactive in thinking through how do we mitigate the risks as opposed to stick our head in the sand and hope it all goes away.
And can I ask a related question? I can see there's one more question after that. But what governance do you think we need in this space to address some of these issues? And in particular, is there an example of best practice globally that you could point to?
So a couple of examples. I mean, this is an active period of debate at the moment, and many of you here will know that within the Australian federal government there have been a number of consultations going on at the moment in the context of safe and responsible AI, looking at the application of, does the Australian Privacy Act cover everything we need it to? Is there additional regulation that's needed? We're seeing this going on around the world. The United Kingdom is about to host a Safe AI Summit that I know we have Australian parliamentarians participating in. The European Union is publishing its EU AI Act, which looks to put guidelines and regulations in place. So it's a very active field of debate and discussion. The EU, to some extent, is ahead of some of this discussion. In part because of the work that they did before around GDPR, and then the rest of the countries in the world sort of lined up around it. But we've got researchers from our legal faculty at Monash University who've been examining all of these regulations in the context of how do we enable freedom of action at the same time enable protection of rights. So I don't know that I would give a best practice example, but I know that the dialogues going on around the world at the moment, the United States, the United Kingdom, Australia, Germany, and the EU Act are probably leading the way in the conversations around this responsible and safe AI discussion. Did you want to add anything, Dan?
Yeah, I might add. So if I might add to that from the technological point of view, I usually view AI, the debates on AI these days, on like two sides of a coin. On one side of this coin, we're talking about developing the technology, developing trustworthy AI. So that is just purely for the technology. On the other side is how you want to use the technology. So that is the responsible use of AI. So it's two different sides of the same coin. Now, I think that in addition to have this regulations and generated AI legislation, for example, it may be something that we might want to consider. Then on the technology side, remember that it's also catching up so that it can give the people who want to use the AI technology or want to regulate AI technology would have the right tools or to be able to enforce that. For example, there's technology where every image that you've taken, you can just do a small perturbation, like you're adding a small signal to it, then any algorithm now that use that image to generate something else, that will be completely doesn't work, right? So there's the technology side. So basically, what it calls is that you make sure that when the generative intelligence or algorithm want to use that image or input, the gradient will be, doesn't work anymore, right? So there's also the technology side to that.
And we've just got time for one quick question.
Well, you've pretty much answered it. Your question was spot on. I was going to say, practically, how do you enforce a governance framework? The countries you mentioned, Germany, Australia, United States, even the EU, they can't get Google, Microsoft and Apple to pay taxes. How are we going to trust them to manage the governance framework?
Yeah, it's a fantastic question. And in fact, Australia does have an AI ethics framework and an AI roadmap. And one of the things that I get involved in lots of discussions like this, we can set guidelines and frameworks around, but practically, how do you encourage companies to comply with those frameworks? One of the things that we see go on within companies at the moment, and it's increasing, is the societal pressure on a company to put, in essence, a chief ethics officer in place, or to have governance at the board level around responsible use of technology, not just AI, but technology more generally. And shareholders increasingly are holding their corporate boards to account in governance and responsibility. And we've seen this before in the context of of environmental and sociological obligations, corporate social responsibility indexes. We're seeing it come in now at corporate board level in a discussion around, well, are we being responsible in our use of AI? So the role of government, I think, is very much to set the guardrails, the guidelines, but ultimately those companies have to comply with or ensure compliance with through their corporate boards and their corporate governance. And the marketplace will show acceptance. Trying to get the big tech companies to pay their taxes is a whole bigger can of worms we could probably spend the afternoon discussing. But in the context of AI governance, increasingly we're seeing a policy request at the board level and the CEO to have a responsibility around how the technology they build gets used in practice.
I'd love to let you have another go, Din, but we'd better stop in the interests of time. I would add, before I ask you to formally thank the speakers, that they're both available for follow-up discussions should you wish to do so. So if you would like to have further discussions, please contact them via the Parliamentary Library staff, and you're welcome to continue the conversation. But otherwise, can I get you to formally thank both our speakers for excellent presentations? This is the last presentation for the year, so ATSI would also like to thank the Parliamentary Library, especially you, Carolyn and Deborah, for hosting us and organising these presentations, and also for Annie, who I missed there, but yes. So thank you all, and we will look forward to having some more sessions with you next year. Thank you.